इस प्लेलिस्ट में आपको मिलेगा मशीन डिजाइन का पूरा रिकॉर्डिंग्स। तो चलिए शुरू करते हैं।
All of you must have seen that sometimes when you bring or this tiffin is brought. Okay, so this is the box in which your food is kept, and then there is a lid. This is the lid. This lid will fit something like this, and it will fit on this. Sometimes you must have seen that aluminum foil is placed on it. So there is a box, this is the base of the box, then this is a lid. When we purchase it from the market, that time is there any aluminum foil provided with the box? No, it's not provided. Why it is not provided? Because it is assumed that whatever food is kept or whatever thing is kept inside this will not come out of this. But then if you are putting some liquid in this, maybe some liquid product, then there are chances, mind my words carefully, there are chances that the liquid may come out of this. And in order to prevent the liquid coming out of this, what is generally done, maybe your mother or sister who is packing the food, they are putting this aluminum foil. And what is this aluminum foil doing? It is preventing the food to come out of the box. You must have seen this, not in this sense, but some or other sense you must have seen this, that we are using something to, so that this lid should fit tight, and whatever is inside that should not come out. So what is this aluminum foil doing here? What is the aluminum foil doing here? When the container or this box was manufactured and it was sold to us, that time there was no instruction given that okay, you have to use aluminum foil, or you will have to use some newspaper, so that whatever you are putting inside should not come out. Maybe not the food, but the oil present in the food may come out of it. And we have seen many times that the notebook, this portion of the notebook, either the top or bottom of the portion of the notebook becomes oily. Why? It's because of the oil which leaks out of the tiffin box. And then if you put aluminum foil, there are chances that it may not happen. So what is this aluminum foil doing? It is something which is used as for the safety purpose, safety of books, safety of other materials which are kept along with this tiffin box. Okay, so understand one thing, that it is not recommended, it is not told, but then it is to be done in order to provide safety to other things. So this is just an analogy which will help you to understand what exactly is factor of safety. Another example that I can give you, so these are of the mechanical examples. Another example that I can give is, no, what do you understand by this word factor of safety? See, this is a factor. Factor means a number. It is a number, and it is taken for the purpose of safety. It is taken for the purpose of safety. Suppose you are going on a vehicle. You are going on a vehicle. Suppose a bike, and you know that you have to travel say 100 kilometer. You have to travel 100 kilometer, and then what you do? You first check whether there is sufficient petrol in the bike or not. And if you see that okay, this is the speedometer or odometer, here you see that okay, this is the red range region, this is the green region, something like this, and your fuel indicator is somewhere here, and you are sure enough that 100 किलोमीटर तो चला ही जाएगा, आसानी से चला जाएगा. Maybe sometimes someone who is sitting as a pillion rider, he will say अगर डाल लेते हैं 100 रुपए का और पेट्रोल डाल लेते हैं, नहीं बीच पे पेट्रोल पंप नहीं मिला तो something like this argument happens with, maybe it may have happened with you. So what are you doing? You know that okay, this is sufficient, but still you are doing something extra. You are doing something extra. So what is this? This is safety purpose, for the safety that you reach safely to the particular location where you want to go. So again, this is an analogy to what is factor of safety. So what is factor? Factor is a number. This number indicates safety. So the 100 rupees petrol that you have put, that is a factor for the safety to reach to the required destination. So these are not directly related to what is factor of safety in engineering, but then these examples will help you to understand कि factor of safety क्या होता है, हम क्यों करते हैं, just to remain safe. So material also wants to remain safe. Are we designing the material so that it should fail? No, we don't want the material to fail. We want it to be safe enough. एक और example दे सकता हूँ. You must have seen a waiter in a hotel. He is carrying glasses like this in a tray. He is carrying glasses like this in a tray. Sometimes what may happen that the tray may have space for 5 or 6 glasses, but he is carrying only 3 glasses. It may be because he is capable enough of handling only 3 glasses. There may be another waiter, same tray he may be having in his hand, and he may be having 5 or 6 glasses, because he may be capable of handling 6 glasses of water. So what is this person doing? This person, he knows that okay, मैं 4-5 ग्लास तो आसानी से उठा सकता हूँ, बट आई एम श्योर दैट 3 ग्लासेस रहेगा तो मेरा ट्रे गिरेगा नीचे से, हाथ से नहीं गिरेगा नीचे. आई कैन इजीली टेक इट फ्रॉम दैट kitchen area to the table where the people are sitting, and this person is confident enough ki I can easily take 6 glasses in a tray. Okay, he must be going to gym every day, so he has that much capacity, and he may be confident enough that he can handle 6 glasses of water, but this person may not have that capability. So the factor, if he can handle 5 glasses but he is taking only 3 glasses, means what is there here is a factor of safety. He has kept the safety of 2 glasses. 2 glasses में कमी रखता हूँ ताकि क्या होगा, मैं गिर ना जाऊँ, ट्रे गिर ना जाए. So these are some of the analogies to understand factor of safety. The factor of safety, what is it? It is a number. And how it is obtained? It is obtained as the ratio of maximum stress to the working stress. But if I ask you definition of factor of safety, what will you say? Factor of safety is a factor. It is a factor taken for the purpose of safety of the product that you are using, product or equipment that you are using. So this particular thing is not the definition of factor of safety. It is just a mathematical way written in the form of sentence. Now, what is this maximum stress? This is what?
Permissible stress?
Yes, maximum stress is permissible. So if I talk in terms of number, how we have decided 220 divided by 110 is equal to 2. So this 2 is what? Factor of safety. What is this 220? This is maximum stress. And what is this 110? Working stress. Now what do you mean by working stress? It is the stress at which we will design the part. So it is called as design stress. And this is maximum stress, permissible stress, safe stress, nominal stress, allowable stress. There are different names given to it. All of this word have similar meaning in terms of this factor of safety. So this is how factor of safety is defined. Now, what is the maximum or allowable or permissible or safe or nominal stress for ductile material? It is yield point stress, because yield point is considered as a point where we at which we design. So for ductile material, it will be this, and for brittle material, there is no yield point. It will fail automatically, it will fail without any intimation. So that is what at ultimate stress. So for brittle material, it is ultimate stress. Stress is also called as design stress, permissible stress, safe stress, allowable stress, or I'm sorry, this is not nominal. It's my mistake. It is normal stress. It is normal stress. So be aware of this word, allowable, permissible, safe, design, or normal stress. And this working stress is also called as design stress. Why design stress? Because it is the stress 110 at which we'll design the work material. Anyway, so we are talking about this ductile and brittle material. So you can see that factor of safety here, the denominator remains the same in all the three cases. Numerator changes. Numerator changes. For ductile material, it is yield point stress, and for brittle material, it is ultimate stress. Now you have studied the stress strain curve, all of you. Okay, in stress strain curve, no, I may not be able to draw it properly here, but then it is something like this, and then something like this. Okay, ये curve नहीं आया बराबर. Here we have proportional limit, then we have elastic limit, then we have upper yield point, we have lower yield point. Somewhere here we have ultimate. We have ultimate stress, and then here we have two part. Somewhere here we'll get fracture. So all of you have seen this stress strain curve. Now this stress strain curve is for which material? Is it for ductile or brittle material?
Sir, this is for ductile material.
Yes, this is for ductile material. Very good. Now this is for ductile material. So we have here proportional limit, elastic limit, then upper yield point, lower yield point. I will draw a stress strain curve for brittle material, and it is actually this is a straight line, something like this. And here only we'll get a fracture. So this is for brittle, and this is for ductile. So in case of brittle material, what happens? The material will suddenly fail. For example, a plastic scale, a chalk. ओके कास्ट आयन, अभी कास्ट आयन तो ठीक है, वो थोड़ा डिफिकल्ट है ना. कास्ट आयन, चॉक तो इजी है. इफ यू ट्राई टू ब्रेक अ चॉक, प्लास्टिक का पेन है कोई थोड़ा, तो वो भी फटाक से टूट सकता है ना. सो दैट ग्लास है, दैट इज ब्रिटल मटेरियल. इट कैन फेल विदाउट एनी इंडिकेशन. इट कैन फेल विदाउट एनी इंडिकेशन. फटाक से टूट जाएगा, बोलेगा नहीं मैं टूटने वाला हूँ करके. एंड देन दिस स्ट्रेस इज द अल्टीमेट स्ट्रेस. द स्ट्रेस हियर इज द अल्टीमेट स्ट्रेस, and that stress is taken here. So in case of brittle material, ultimate stress upon working stress. अभी ultimate stress कौन सा stress है? ये वो stress है जिस stress पे material टूट रहा है. I think it is clear to all of you. For brittle material, that is like cast iron or glass or scale or chalk, the factor of safety is defined as ultimate stress upon working stress. Ultimate stress क्या होता है? ये वो stress होता है जिस stress पे material टूट रहा है. Breaking of material breaks. Okay, so that is factor of safety. Working stress के बारे में बाद में बोलता हूँ, पहले ये न्यूमरेटर देख लेते हैं. Now come to ductile material. Now in case of ductile material, where is the ultimate stress? Ultimate stress is somewhere here, and we are not taking this ultimate stress. We are taking what? We are taking the yield stress. We are taking the yield stress here. You can see yield stress, yield point stress or yield stress. And we are not taking the ultimate stress. Why we are not taking ultimate stress? We should have taken ultimate stress, because at ultimate stress the material will fail. Material will fail. यहाँ पे टूटेगा material, थोड़ा आगे जाके टूटेगा. But this is the stress at which you will get a material as we can call it material is failed here. Failure has occurred here. So why are we not considering this ultimate stress? We are considering yield stress. Here, in case of ductile material, whenever there is yielding, when this yielding happens, yielding will happen at yield stress or yield point stress. So this is the stress before which what we have elastic limit. So yield point means material will start to elongate. Okay, and when material will start to elongate, that time the material is considered as failed. Why? I will tell you why. Consider this shaft. Okay, it is mounted in bearing here and one bearing here, and on this shaft I have mounted a gear, and this gear is a spur gear, and it is rotating in mesh with another spur gear or pinion, whatever you want to say, and they are rotating in mesh with one another. Okay, अच्छे से चल रहा है ये गोया, इस पे रोटेट हो रहा है इस गियर की वजह से, और कुछ तो वहाँ पे और दूसरा ऑपरेशन हो रहा है. Now what happens? Because of the weight of this gear, or there are forces also which are acting in downward direction, what will happen? It is possible that the shaft will elongate something like this. Now see, I am exaggerating it. इतना elongate होगा नहीं जितना मैं दिखा रहा हूँ, मैं exaggerate कर रहा हूँ तभी तभी तो समझेगा. So the shaft which was earlier horizontal, perfectly horizontal, is now elongated like this, elongated. Okay. So when this will elongate, that time what will happen? That time this gear will not mesh properly with the pinion. It will not mesh properly with the pinion, and that's why whenever there is elongation of the shaft, that time we consider it as failed. And this elongation begins at the yield point stress. At the yield point stress. That's why we will not wait for the ultimate stress to occur. We'll always design it at the yield point stress. So in case of ductile material, whenever a material whenever yielding of the material start, it means that the material will start elongating, and this elongation will not come back to its original shape and size. And that's why in case of ductile material, we consider yield point stress as the maximum stress. So is the concept of maximum stress clear to all of you? If anyone has doubt, you can ask me. Maximum stress is yield point stress for ductile material, and maximum stress is ultimate stress for brittle material. Hope this is clear to you. Now we will come to this working stress. Now what is working stress? अभी मैंने यहाँ पे example दिया था. See, this fellow who is holding this tray in his hand. Okay, he is capable of holding more than 3 glasses, but he is holding only 3 glasses. He is capable of holding more than 3 glasses, but he is holding only 3 glasses. So what is his working stress? Working stress can be 3. Now this fellow who is holding 6 glasses, his capability may be 6 glass or more than 6 glass. It's his capability of holding the tray with 6 glass full of water. So it may be either 6 or more than 6. But then he is how many glasses he is bringing here? He is bringing 6 glasses. So what is the working stress here? The working stress is 6. Okay. Now I will relate this to the mechanical example. Okay. Working stress is also called as design stress, permissible stress, safe stress, or allowable stress. Or I'm finding the eraser here. Actually, the logo is coming, so I am not able to find the eraser. Where is it? I got it. So this working stress, it is also called as what? You can see there are another word, different words used for it. The words are design stress, or permissible stress, or safe stress, or allowable stress, or normal stress. You can note down these words because these are very important words. Every time this design stress or working stress may not be there. So what is working stress? What is working stress? It is the stress at which the material is designed, and it is also called as design stress because it is the stress at which the material is designed. What do you mean by material is designed? That I will tell you in a moment. So it is the stress which is permissible. बस इतना ही stress है, इससे ज़्यादा नहीं जाना है. It is the stress which is a safe stress. Okay, this much is safe. Don't go beyond this. It is a stress which is allowable. Okay, this much we allow you only this much, or it is a normal stress. So understand what do you mean by this working stress or permissible stress. For example, consider a material and its ultimate stress. From where will we get this ultimate stress? We will get this ultimate stress from the design data book. Let it is 60 Newton per mm square. Ultimate stress of a material is 360 Newton per mm square. Now, if I want to design the material, what I will do? I will use the formula load equal to area into stress. Is it a new formula for you? No, it is not a new formula. All of you know that stress is equal to load upon area. So load is equal to area into stress. I know the value of load. Suppose the load acting is say 50 kilonewton, or for reference we will keep it 50 only. Okay, 50 Newton only. So I will put the value 50 equal to, suppose it is a circular part, then area will be pi by 4 d square into what is the value of stress, 360, and from this, after solving this, I will get the diameter of the part. So try to understand this. The ultimate stress for the particular material is 360 Newton per mm square. And I am saying that the force is 50. Okay, force is 50. Area is to be found out. मतलब हम क्या कर रहे हैं? We are designing the diameter of that part. Area is to be found out, and stress is known as 360 Newton per mm square. Okay, and we will get the value of diameter. Now, how will we do the calculation? Pay attention here. 50 into 4 upon pi into 360. Okay. Now, if 360 is taken, and what will happen if this load increases from 50 to 70? Load increases from 50 to 70. If the load increases from 50 to 70, this diameter may not be suitable. It may break. This diameter may break. The part may break because of this diameter. So what will we do? Instead of designing it as a stress of 360 Newton per mm square, what will we do? I will say that instead of taking 360, I will consider a factor of safety, and that factor of safety is equal to 360 divided by working stress. So working stress is equal to 360 divided by factor of safety, and I have taken factor of safety as 4. So working stress is how much? 90 Newton per mm square. So I will say that instead of designing this as at 360 Newton per mm square, I will design at 90 Newton per mm square. And what will happen because of this? Because of this, the diameter value will increase. Diameter value will increase, and it will be sufficient enough to bear the load of 70 Newton. Factor of safety, see, factor of safety is yield point stress upon working stress. So I want now yield point stress. So yield point stress is, how will you find the yield point stress? अल्टीमेट स्ट्रेस, ये जितना भी है अल्टीमेट स्ट्रेस, इसको डिवाइड कर देंगे फैक्टर ऑफ सेफ्टी से, तो हमको क्या मिल जाएगा? यील्ड पॉइंट स्ट्रेस मिल जाएगा. सो आई विल डिजाइन दिस पार्ट जिसका हमने एरिया फाइंड किया, नॉट एट 360 न्यूटन पर mm स्क्वायर बट एट 90 न्यूटन पर mm स्क्वायर. दैट्स व्हाई सी दिस स्ट्रेस इज कॉल्ड एज वर्किंग स्ट्रेस. मतलब मैंने जो वर्क किया वो कितने स्ट्रेस के लिए किया? 90. I have designed it for what stress? 90. So design stress is 90. I am saying that you cannot exceed beyond 90. So 90 is permissible stress. I am saying that if you design at 90, the design will not fail. So it is a safe stress. Again, permissible और allowable का एक ही मतलब होता है, and it is the normal stress. So is this concept of factor of safety clear to all of you? If anyone has any doubt, you can ask me. Now coming to this flyover bridge. Now if you see that if it is designed for say 10,000 ton, at a time the load on this may be more than this. If there is traffic on bridge, then there may not be any space, and there may be more vehicles here, like this. Okay. Sometimes the vehicle carry, if these are trucks, then the weight will increase. Now in that case, if it is designed for say 10,000 ton and the weight increases more than 10,000, what will happen? All of a sudden this should fail, this pillar should break. All of a sudden the pillar should break, and it should break, and the bridge should fall down, it should collapse, but it does not happen. So in such case, there is a need of taking factor of safety. This is another example where we need factor of safety. Let me take another example. The third example I am taking here is a motor. Suppose there is a motor. So this is a motor, and from this motor there is a shaft rotating, and then there is a belt here, and this is connected to say there is pulley and something like this. So this is a belt and pulley arrangement. Though this motor is of 3 HP, 3 horsepower. Okay, so P is equal to 2 pi Nt upon 60. So how much torque it will generate? So if we know the value of RPM, we will know it will generate some torque. It will generate some torque. Okay. So if sometimes because of the sometimes it may happen that the horsepower is 3 HP, but if it increases slightly because of the fluctuation or something, if it increases, then what will happen? The torque will increase. The torque is taken up by this belt. The torque is taken by the belt, and the belt is designed for taking the torque which is designed for 3 HP motor. Then what will happen? Suddenly the torque will increase and all of a sudden the belt will break. That is, it will fail. So it can be, the factor of safety can be also be for the motor also. It can be for motor also. Okay, so it will be, if I take 2 as factor of safety, then this will be designed for 1.5 HP, this much power only, so that the torque will be accordingly. And this, if it is designed for 1.5 HP and if it increases to 3 HP also, then also it will not fail. Okay, let me take one more example here. Maybe a mixer or a microwave oven at your home, or maybe a washing machine. No, mixer generally it is overloaded. It is overloaded, one thing. Second thing, the time. Suppose you are grinding something in mixer, and then it is recommended that you should grind for 25 minutes and then you should give a break of 5 minutes. You should give a break of 5 minutes. But then this is never followed at home. You must have seen it is continuously grinded for 30, 35, 40 minutes. Sometimes in hotel also you must have seen this. Mixers are used. Even the microwave oven. Okay, it may exceed the given time limit. Given time limit. Same thing can happen with washing machine. Then it will happen with geyser. If there are guest, suppose guest in home, then continuously this geyser is kept on for some particular time, and which exceeds the recommended limit. So in that case, what will happen? In that case, all these appliances may fail. So it is designed for more load. For example, if they give the time limit of 25 minutes, they will always design it for a time limit of 50 minutes. Then it means the factor of safety is 2 roughly. Same is with all the other cases. One more example if I take, then it can be of a, say, tightening of a nut. Tightening of a nut. Have you ever tightened a nut? If there are 4 nuts like this, if there are 4 nuts, then you have to tighten it in a sequence that if you tighten this, then you have to tighten another which is in cross, and then this, and then this, and then you have to partly tighten it, and then you have to tighten it finally. Okay, so you cannot first you tighten this fully, and then you tighten this fully, then you tighten this fully, and that's this. This is not recommended. And the product or the screw which are designed, or the threads rather which are designed, are not designed for this thing. In fact they are pneumatically tightened. And what are we doing? We are using a spanner here, and sometimes if it is not possible, you may even stand on this spanner. जोर लगा के stand खड़े होके you will try to tighten it, ताकि वो चक्का निकल ना जाए और टायर आगे भाग ना जाए. You do it sometimes. You must have seen mechanics also doing it sometimes. So in order to prevent the failure of threads in such cases, factor of safety is provided. Okay, so what are examples I have given to you? There are many examples written with me. So in order to accommodate these things, there are the factor of safety is given. You may be asked in the examination why factor of safety is given. All of you know what is factor of safety. All of you know how to find the permissible stress by taking factor of safety. But you may not be knowing why this factor of safety is given. Then another example can be given is of wear of the part. Wear of part. For example, you have designed a particular part. For example, a gear. A gear is designed. You have considered some factor of safety, or maybe not consider a factor of safety, and it is designed. Now what happens? Gear always runs in mesh with the pinion. Suppose the oil that is or lubrication that is provided, it is less, and the entire teeth are not lubricated. Then what will happen? There may be wear. There may be wear in the gear. Okay, there may be wear. Now, in order to accommodate this wear, again factor of safety is provided, so that in case if something like this happens, then it may not fail. It may not fail. Okay. Then another example that I can give you here is of manufacturing. Manufacturing. Whenever a part is manufactured, that time there is some tolerance given. There is some tolerance given. Also, there is some acceptance sampling. You will learn this in MQE metrology. What is acceptance sampling and all that. So let me tell you quickly about what is this. If this lot of 100 pieces is prepared, then it may happen that only 2 samples are checked. 2 samples are checked randomly, and all the 100 samples may not be checked. Or sometimes it is destructive testing. So you will not destroy all the samples, then you will have nothing with you. So only 1 or 2 samples are checked. It may happen that out of the 2 samples, or 99 samples may be correct and 1 sample may not be correct. Here also there may be some excessive tolerance given in some of the part beyond what is specified. Then it may lead to some or other type of failure. To prevent this, or to accommodate this type of errors, we need to give factor of safety. Okay, so these are some of the examples which will explain you, which will make you understand why this factor of safety is given. So I think you must have understood by now कि factor of safety देते क्यों है. Any doubt to anyone why factor of safety is given? Okay, so things are clear till here. Why factor of safety is given? Now this factor of safety is governed by certain factors. Now if you have understood this why factor of safety is given, then these slides are very easy for you to understand, and I can run through it. See, type of load. If it is a static load, then what will you do? The factor of safety value will be low, because static load does not changes. Okay, so मैं ऐसा बैठा हूँ, मेरे हाथ में कुछ लेके मैं बैठ के रख सकता हूँ ना. Static load है, कुछ नहीं change हो रहा है. But then if I am dancing by holding something, I am holding 3 glasses of water in my hand and I am dancing, or I am keeping this glass of water on my head and standing or sitting, it may not fall. Static load. But if I am moving, it may fall. Definitely it may fall. So for a static load, the factor of safety will be low, and for a high load, high impact load or variable load, it will be high. Then it depends on it depends on material also. For ductile material, the factor of safety is taken as low, and for brittle material, it will be taken as high, because brittle material does not give any invitation for failure, whereas ductile material will give the intimation that yes, I am going to fail. So you will see through this through this slide that whenever we know or we can predict the situation, that time we will take the value of factor of safety as less. Static load hai, ductile material hai, cost of the material is less, then we will take factor of safety as less. And if the material is costly, then we will take it as high. Why? Because if it is a costly material and if it fails, then you are wasting more money. But if it is a low cost material, सस्ता मटेरियल है, टूट गया तो फिर से ले सकते हैं. That is the concept here. Then reliability of property of material and their changes during service. How much reliable the material is. For example, if you select a glass, and for that same purpose, if you select wood, okay, so which is more reliable? Wood is more reliable as compared to glass. Okay, Then the nature of distribution of stresses, whether the stress distribution is uniform or not uniform, that also governs the factor of safety. Then life, danger to life or property, अगर फेलियर होता है, एक्सीडेंट होता है, उससे बहुत लोग मरने वाले हैं, तो व्हाट विल वी डू, विल सिलेक्ट हाई फैक्टर ऑफ सेफ्टी. एक्सीडेंट नहीं होना चाहिए, पीपल शुड नॉट डाई. एंड इफ देयर इज नो डेंजर टू द लाइफ, ठीक है, हादसा हो भी जाता है, एक्सीडेंट हो भी जाता है, तो किसी का जान नहीं जाएगा, किसी का हाथ नहीं टूटेगा, कुछ नहीं टूटेगा, हमको पता है. सो वी कैन टेक लेस फैक्टर ऑफ सेफ्टी. देन सर्विस कंडीशंस, इफ इट इज अ करोसिव एटमॉस्फेयर, अगर धूप में खड़ा रहना है तो हम ज़्यादा पानी का स्टॉक रखेंगे, एसी में बैठना है तो पानी का स्टॉक कम चाहिए. Okay, that is service condition. Exact mode of failure is known. See, exact mode of failure of a particular product, if it is known to us, then what will we do? If it is unknown, then high mode, if it is unknown, if you don't know how the material is going to fail, then what will we do? We will select high factor of safety. एक घर है, उस घर में हम क्या करेंगे, अगर घर में बहुत पैसा है तो हम 2-4 सिक्योरिटी लाके रखेंगे, पता नहीं चोर कहाँ से आएगा, किधर से लेके जाएगा. अगर पैसा कम है, पता है कि कोई चोरी होने वाला नहीं है, तो व्हाट विल वी डू, will not have any more security, amount of security or the quantity of people who are guarding will be less, something like that. I'm just giving examples so that you can remember these things. Then quality of manufacture, if it is a China product, then it can be a low, it can be it will be of poor quality. Okay, if it is a poor quality, then it should have a high factor of safety, but it's not there in case of China product. The quality is also poor and the factor of safety is also low, but ideally it should be like this. If your product quality is not good, जो प्रोडक्ट लिया है, हमने परचेस किया है, जो मटेरियल परचेस किया है, वो मटेरियल ही अच्छा नहीं है, उसमें ही यूनिफॉर्मिटी नहीं है, तो हमको ज़्यादा मटेरियल रखना पड़ेगा ताकि वो मटेरियल फेल ना हो. If the material quality is high, then you can have low factor of safety. So this I have explained you what are the various factors that govern the factor of safety. So what are the factors? Type of load, type of material, then the cost of component, then the reliability of the property of material, then distribution of stress. If the stress distribution is known, then we can have less factor of safety. Then other factors are danger to life or property, service conditions कैसा है, mode of failure पता है कि नहीं, quality of manufacture कैसा है. So all these are the factors that governs the factor of safety. Governs the factor of safety मतलब इन सबको लेकर हम पता करेंगे कि factor of safety कितना रखना है हमको. Then for higher factor of safety, what will we do? The value of factor of safety should be high in the following cases. अभी जो मैंने एक्सप्लेन किया सेम चीज आप मैं फिर से रीड करूंगा, सिर्फ ये पॉइंट अलग है कि फैक्टर ऑफ सेफ्टी हायर कब रहेगा. So low strength of material is less. Not strength of material is not the subject. Strength of material मतलब material का strength. If it is low, then you should have high factor of safety. If there is heavy or impact load acting on the material, then the factor of safety should be high. If there is fluctuation in load कम हो रहा है, ज़्यादा हो रहा है, कम हो रहा है, जा रहा है, then it should be high. If you want longer service life, then you should select high factor of safety. If the extent of loss to life and property is more, then high factor of safety has to be selected. If there is uncertainty about temperature, बीच में टेम्परेचर बहुत बढ़ रहा है, प्रेशर बढ़ रहा है, ह्यूमिडिटी बढ़ रहा है, मटेरियल इज नॉट एबल टू कोप अप विद द डिफरेंट चेंजिंग एनवायरनमेंट, देन यू शुड हैव टू सिलेक्ट हाई फैक्टर ऑफ सेफ्टी. स्ट्रेस कॉन्सेंट्रेशन इज मटेरियल इज मोर, देन यू शुड सिलेक्ट हाई फैक्टर ऑफ सेफ्टी. नाउ व्हाट इज द स्ट्रेस कॉन्सेंट्रेशन? एक पूरा टॉपिक है हमारा स्ट्रेस कॉन्सेंट्रेशन में, तो क्विकली आई विल टेल यू हियर, विद इन अ मिनट आई विल ट्राई टू एक्सप्लेन. सपोज दिस इज अ रेलवे ब्रिज. ओके, ये प्लेटफॉर्म नंबर 5 से आ रहा है, ये प्लेटफॉर्म नंबर 6 से आ रहा है, यहाँ पे कोई एक प्लेटफॉर्म नंबर 6 से आ रहा है, सपोज ये 7 से आ रहा है. ओके, द ट्रेन हैज कम, ट्रेन हैज अराइव्ड, एंड आफ्टर द ट्रेन हैज अराइव्ड, द पीपल, ट्रेन हैज अराइव्ड ओनली एट प्लेटफॉर्म नंबर 5 हियर, and then the people are coming here and they are going, some are going in this direction like this. They can freely move, they can move freely, but consider that instead of one train, 3 train comes. Train has arrived on 5, arrived on 7, arrived on 9. Then you can see a mess of people going here and there. So are these people now free to move? No, they are not free to move. What is happening here? There is concentration of people, or you can say there is crowding of people. There is crowding of people. So if it happens in the material, then it is called as concentration of the material. So when it happens when this is the material, and if you create something like this, a notch in the material. तो ये लोग जो ऐसे जा रहे थे पहले प्रॉपरली जा रहे थे, ये क्या होगा, दे विल गेट कॉन्सेंट्रेटेड हियर नियर द नॉच. यहाँ पे you can see it is comparatively more concentrated in this area as compared to this and this area. This is called as stress concentration. तो इसके वजह से भी material fail हो सकता है. So if there is a condition where there is stress concentration, then you have to select higher factor of safety. I will talk on this stress concentration. एक पूरा बहुत बड़ा मॉड्यूल है हमारा stress concentration पे. So अभी के लिए इतना sufficient है. मैग्नीट्यूड एंड नेचर ऑफ फोर्सेस कैन नॉट बी एग्जैक्टली नोन. कभी भी कोई भी आके फोर्स बढ़ा देगा, कैसे भी फोर्स लगेगा, बीच में ही आंधी आ गया, तूफान आ गया, तो बिल्डिंग गिर सकता है. ओके, तो देयर यू हैव टू सिलेक्ट हायर फैक्टर ऑफ सेफ्टी, है ना. इट्स क्वाइट लॉजिकल. इफ यू आर बिल्डिंग अ होम व्हिच इज नियर टू द सी, then the wind pressure will be more, wind pressure will be more, so you naturally have to build it more strong. But if you are building it in some area where there is no wind or very less wind, comparatively less wind, then in that case you can have less strength of the building can be less as compared to the earlier case. And non-homogeneous structure of machine component. अगर material is not homogeneous, कहाँ पे उसमें ब्लो होल है, कहाँ पे उसमें थोड़ा एरर है, क्रैक्स है, ऐसा अगर मटेरियल है तो वो तो मटेरियल भरोसे का नहीं है. सो इन दैट केस यू विल हैव टू कीप हाई फैक्टर ऑफ सेफ्टी. एंड एग्जैक्टली अपोजिट टू दिस इज व्हेन यू हैव टू कीप लो फैक्टर ऑफ सेफ्टी. These are the cases where you can keep low factor of safety. I think our time is over. Yes, 51 हो गया. So we'll stop here today. What I have explained today is a concept of factor of safety. Now understand this factor of safety. In most of the cases, in most of the colleges, this is a 5 minutes topic. कितना 5 मिनट का टॉपिक है. I have taken more than 50 minutes for factor of safety, and still I have not completed. I have to explain something more about it, about factor of safety. Okay, so that also I will quickly explain you. Okay, I will take 5 more minutes to explain that. So don't leave. So see, this is the difference. The same topic can be explained in 5 minutes, and same topic can take more than, you must have seen how much time it has taken. I mean to say, if factor of safety is more, see this upward arrow indicates more, then cost will be less. B, cost will be more. C will be not affected, will not be affected. Any answers? A, B or C? If factor of safety is more, cost of the material will be more. So B option.
Yes, sir.
Come on quickly, I want each one of your light to be flashed here. I can see your names. Come on quickly, unmute yourself and tell me the answer. A, B or C, all of you. Or put in chat box, A, B or C, quickly. Put it in chat box quickly.
B.
Put either A, B or C in the chat box, all of you. I'm not getting any messages. So all are gone. Okay, who can explain this? Who can explain this? Why B?
Sir, as we have seen in that example, when factor of safety was increased, the area was increasing, the diameter was increasing. So sir, more material will be required in order to compensate for
Yes, if factor of safety, correct, Amay. If factor of safety is more, that time what will happen? Area will increase. Okay, so let me explain this here. We know that stress is equal to force upon area. So I can write force equal to area into stress. Now, stress if less factor of safety and if the factor of safety is more. If the factor of safety is more, then stress will be less, and if the factor of safety is less, stress will be more. Are you getting this? If the factor of safety is less, you have created less factor of safety, then the stress will be more, stress value will be more, or I will say permissible stress will be more. And if the factor of safety is more, then the stress value will be less. So if you select more factor of safety, then the stress value will be less. Stress value will be less. If the factor of safety is more, then the stress value will be less. Stress value will be less means area will be more. And what is area? Suppose it is a circular rod, then area is pi by 4 d square. Less the value of stress, more is the area. More is the area means more is the diameter. More is the diameter means more is the cost of the material. So this way also you can prove that the effect of factor of safety on material cost. So this can be a gate question, 1 mark gate question. What is the effect of factor of safety on material cost? Or it can be asked in any other way.